That's it? That's the end of week 9 then? We can go on to week 10? This is where the video starts? Week 10. All right, that was the pause for editing. Here's the instructions. No, that's not the instructions. Here's the instructions. Look, you have one assignment. The Excel and written are together on one assignment. It really should be called written Excel table assignment because part of your assignment is showing that you can use the new tables you're going to learn today. Binomial distribution table and Poisson table. Due a week from today, March 23rd, before class starts. Here's the usual stuff down here. Here's the bad news. Let's say, and only about one of you might want to start your homework early. For some reasons, usually you guys don't, but when you go to click on it for the first time, this is what you'll see. Usually you'll see an assignment, but not this week. Right now, you have coming soon. I will be posting the assignment either tonight or tomorrow because I'm changing it so much I couldn't get it finished. So the previous semester's assignment didn't have the table involved, so I'm making a bunch of changes because I want you to have using the table as part of your homework assignments. So it'll be there tonight or tomorrow for anybody who wants to start early. But it's not due till a week, so I know that 99% of you will not even look. Won't even know. I wouldn't even notice I put coming soon there had I not pointed it out just now. You would not even have known this is the case. So there you go. There it is. So I can't even show you the assignment, but there's the instructions like usual. Where do we want to start? Binomial. So we're going to talk about binomial, talk about Poisson, because we're going to make that comparison as to how we do it manually compared to how we use Excel, compared to using the table now. The first binomial problem we learned, now remember this is way back in week 3, and the first binomial table we learned was this example from the PowerPoint. Hang on, let me get to it right here. Evans is concerned about low retention rate of employees. In recent years, management has seen a turnover of 10%. This is your hint that it's binomial, because binomial is the only one that's giving you a proportion already, a past historical proportion or probability, 10%. And the hourly, thus, for any hourly employee chosen at random, management estimates the probability of 10% that the person will no longer be there 12 months from now. So choose 3 hourly employees at random. Now, I want you to be careful there. This says choose 3 hourly employees at random, but normal distribution, where we're heading, starting, matter of fact, on Tuesday of next week, I believe, normal distribution is also going to say, now there's a sample size of maybe 3 employees. So binomial talks about a sample size, and normal is going to start talking about a sample size from this point on. And we're doing a whole bunch of normal distribution calculations in the next several weeks. So I want you to be able to recognize the difference between normal and binomial. Here's the difference. Even though binomial talks about a random sample, in this case, choosing 3 hourly employees at random. Now, right now, you should say, oh, randomly chosen sample. That means it's either binomial or normal. The difference is normal distribution will also describe a standard deviation. Binomial will not. Let me repeat that. Normal distribution and binomial distribution both are going to talk about a sample size here in the future from this point on, but normal distribution is the only one that will mention the standard deviation. Binomial will not. Binomial instead mentions a historical probability, like this one did. In the past, turnover rate's been 10%. That helps you recognize it's binomial compared to normal. That is sentence about the 10%. So now, here's what we've been given. This company historically has 10% turnover with employees. It's asking us to pick 3 employees at random. And now here's the question. It says, what's the probability that one of them will leave the company in a year? What's the probability that one of those 3 chosen at random will no longer be there in a year? We're going to keep an eye on those 3 employees. They don't even know they're part of the random sample. And at the end of the year, what's the probability that one of those 3, not 1 or less, not 1 or more, 1 exactly it says. So our X is a 1, our N is a 3, our P is 10%. Here's the formula we learned way back in week 3. This formula was on quiz number 1. And all we gotta do is plug in the 3, plug in the 1, and the 10%, and then the opposite of 10%, and so on. There's how we set it up. This should refresh your memory a little bit. I want to refresh your memory how to do it with Excel. Go ahead.
Where'd the probability of 10 come from?
In the story, it said, historically, management has turnover of 10% on the hourly employees annually. So it was in the story that historically it's 10%. Again, that's one of the ways you want to recognize this binomial compared to normal. But here's the three numbers that you want to focus on. We were asked to find a probability of 1 employee, we had a sample of 3 employees, and we were given historical percent of 10%. Let's refresh our memory how to solve this using Excel. This wasn't 1 or more employees, this wasn't 1 or less, it just said 1. So equals binomial distribution. X is what we're trying to find the probability of, 1, comma, out of, how many were picked at random, 3, comma, what percent was given to you in the story, 0.10, 10%, and what's on the end? Is this asking about 1 employee out of the 3, or 1 or less, or 1 or more? 1 employee out of the 3, so that means we'll put a 0 on the end. There is how to use binomial distribution with those 3 numbers. And then decide if there's a 0 or 1 on the end. All right, help me make a change here. Hear the word. Remember, binomial and Poisson are the weird ones when you hear these words. What's the probability 1 or more will no longer be with us after we pick 3 employees at random? We usually have 10% turnover. 1 employee or more. So what should I erase? What should I change? Help me out, anybody. Say it again. 0 instead of put a 1 instead of a 0. Change that to a 1 because it was 1 or more. Very good. Absolutely. David, you want to finish this off? 1 minus in front. Very good. He's saying put a 1 minus right there between the equal sign and the binomial. So right now, this is set up to not find the probability of 1 or more. It's set up to find the probability of 2 or more. That's the weird part about binomial and Poisson. What else has to be changed? I've seen in your eyes. Go ahead, Steven.
Change the 1 to the 0.
Right here. He's saying you got to use the opposite, even though you couldn't remember it for his in-class assignment. Oh, sorry. That was Cole's job to throw under the bus, not mine. Is the opposite of what's being asked for. If 1 or more is being asked for, the opposite would be 0 or less. Very good. The opposite. That's what you got to remember for both binomial and Poisson. They're the only ones where you got to use the opposite because it's using discrete data. The other ones, exponential and normal, are using continuous data. It doesn't matter if I said 1 or more or 1 or less. You're still using a 1. You don't have to change it. It's just those 2. All right, very good. Let's try one more. We usually have 10% turnover. We're randomly picking 3 employees. What's the probability 2 or more will no longer be with us? 2 or more. What do I got to change?
X to 1.
Say it again, Steve.
Change the X to 1.
Change this X from 0 to 1 because I said 2 or more. The opposite would be 1 or less. Very good. We got the 1 minus in front. We already got the 1 on the end. All right. Now, are you ready? You're now going to use a binomial table that's posted on Canvas for you to download and have ready to go for your final exam and that you could use during your homework. And the table looks like this. Right there. Is this it? No, that's not it. That's it. Right there. And here's the deal about this. There's 3 numbers involved. I want you to give me the column. That's what I forgot to put up here. I want the column, the row. Wait, I'm sorry, hang on, this has 3 numbers. What is that, N? I want the column, I want the N, and I want the row. This is how you're telling me about your table. If it's binomial distribution, there's 3 things you're giving me as your answer. It's gonna say on the final exam, use the table to solve this. You gotta remember to give me 3 things. What column you're using, what N you're using, and what row you're using. Now, in this particular table, row is really the X. This is really the X. Matter of fact, I'll put X in parentheses right next to it. The N is the random sample size. I don't know, what do I put? Out of. I put that in there. Out of. How many out of? And then the column is that percentage that's given in the problem. Those are the 3. The column is telling me that I should be able to tell by what you wrote exactly where to look on the table based on what you said. So here we go. In this story, I want to remind you, management said we usually have 10% turnover. So there's that part of it. That should tell you what, the row, the column, what are you, I just told you, 10% turnover, what does that get, what did I just give you? The column. That should tell you which column to look for. So now look for the 10% column, I see it. It looks like the third one from the left when we start with the percentages, you see it? Then it said, you're randomly choosing 3 employees to watch for a year. So what did I just tell you, N or row? N. You gotta find N then for 3. Then it said, what's the probability 1 will no longer be with us at the end of 12 months? So that's your row. So in this case, this row would be a 1, N is a 3, and the column is 0.10 for 10%. Let me make this bigger so everybody can see it.
0.243, isn't it?
Yeah, is that what you see? Where?
Eight.
Again, I gotta make it bigger.
0.243.
It's not, there's the 10%, there's the 3, and there's the 1. Let me move it over. There it is, exactly what it said, 0.243. This is 0.243. Put a 0 in front, we want right there. That's how you're gonna use this table. It's almost too easy. Can you believe it? Look at the manual formula we had to do to get that same answer. Look at that, 2.243. Or Excel, same answer. We gotta put all this in, 0.243. Let's do another one. Again, we're going to, you know what? I got another one set up over here. Boom, boom, right here. Can we see it? Bottom of the left-hand page there, example 5.8. I almost gotta look right here to see it. Let's see what we got here. In the United States, about 30% of adults, there we go, hang on a minute. Column and 1, answer. Get this ready, right here, get this, figure out what we're gonna put here, you use Excel also. It says in the United States, 30% of adults have 4-year degrees. Suppose 5 adults are randomly selected. Well, make sure we're doing A. We're doing A and B. A, what's the probability that none of these adults have a college degree? All right, help me out. First, let's go with this up here. Do I need a 1 minus in front?
No.
No, because it's asking for something or less, something or exactly an amount. It says, what's the probability none of the adults need a degree? An exact amount. So what's my X? 0. Out of how many employees?
5.
5. What's our historical percentage?
305.
30%? Say it again.
30.
Did I do something wrong?
30%.
Oh, 30%. Is that what you're saying? 0.30, comma, 1 or 0 on the end? 0. There it is. Equals binomial distribution, 0, comma, 5, comma, 0.30, comma, 0, which gets the answer. Now, let's go to the table. What would be our column on this problem? 30%. So 0.30 would be our column. What would be our N on this table?
5.
Very good. 5. What would be our X? 0.
So
Now, here we go. Let's bring the table up again. Gotta switch this over. Again. Boom. 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 We're going to the 30%. I got my pointer right there at the 30% column. Then you guys said go to 5 for the N. So I'm gonna have to scroll down. I don't even have to scroll down, do I? Look at how unbelievable lucky that was. I'm going down to the 5, which is right here's the 5. Then you said our row is gonna be 0. So I go right there, 30%, and there, is that the answer? Everyone agree? Yeah. 0.168, is that what it says? 0.168, let's look and see what the book says. Anybody has their book, it's page 179, and it was solved manually, and it says 0.1681. Same answer. Can we use this table? We're not done. You can't use this table. You just think you can use this table. Are you crazy? You ready? Look at this table closely. Hang on. Do I have the top row there? That is the top row, isn't it? Yes. So the top row, you can still see it. You ready? I'm changing the question. Yes, 30% of American adults have degrees. We randomly chose 5. We're using this to answer the question, what's the probability there'll be 2 or less with degrees out of the 5? 2 or less out of the 5. We're still using, now here's the deal, we're using column 30%, and we're using 5, but I said 2 or less, so this has to be 0, 1, 2, 2 or less. You gotta look at all 3 of those numbers off that chart and add them together. That's how you do a cumulative one instead of just an exact one. So if I go to this chart now, 2 or less, there's the 30%, there's the 5, there's the 0, 168, there's the 1, 0.360, there's the 2, 0.309. You have to add all 3 of those together. 0.3, 0.3, so that's 0.6, 0.7, 0.8, that's like 0.837. 0.837, adding those 3 together about. But you see what I had to do? Now let's go one step farther. Are you ready? What's the probability there'll be more than 2 adults with degrees? Let me say it again. 30% of adults have degrees. We randomly chose 5 adults. What's the probability more than 2? Let me write this down for you. More than 2 have degrees. Let me erase this. Here we go. 30% still our column. 5 was our size. Hang on, let me get this. More than 2. More than 2. What am I going to do? What? What? Oh, we're doing the Excel? Oh, hang on. We're doing the Excel? Okay, hang on. 1 minus, you're right. 1 minus here, so I'll put that there. What I say again? 2. More than 2.
3.
What number's here?
3.
Come on. I hear a 1 and a 3.
1.
Wrong.
It's 3.
Who said 3? Wrong.
2.
2. Why 2?
Because
More than 2 would be 3 or more. The opposite of 3 or more would be 2 or less. That's why this is a 2. Comma, out of, how many adults did we choose? 5, comma, the percent was 0.30, comma, 1. There it is. 1 minus in front, the opposite of 3 or more, because more than 2 does not include 2. If that said 2 or more, 1 would have been correct. But now, tell me which rows am I using? There's 2 right answers to this, by the way. There's 2 right answers, not just 1. More than 2. I'm looking where the pointer's at, and it's right there at 0.309, which represents 30%, 5 adults, 2 out of the 5, but this says more than 2. So which rows should I use? So I heard it, say it again.
3.
Row 3 is, okay, he's saying row 3, hang on, this is more than 2, so row 3, but that's not it, this is more than 2. Row 3,
4 and 5.
row 4, row 5. We could find the probabilities for 3, 4, and 5, which are all more than 2, but we can't go more than 5 because we only picked out of 5. And we can add those 3 probabilities and get the right answer, or we could have added 0, 1, and 2, add those up, subtract from 1, and also get the right answer. Because if you notice, these all add up to 100%. Every one of these, if you add all 5 of them together, 0 through 5, they would add up to 100%. So we could go either direction. That's why there's 2 right answers to this. Is everybody getting this? Can everybody use this table, whether it's a less than, a more than, or an exact probability being asked for? We can? We're ready to go Poisson now then? Okay, let's go Poisson. Let's do it. Let's refresh your memory on Poisson. This has not been that long ago, so you remember it's how many occurrences during an interval, right, is what the probability is. Like the number of vehicles arriving in a toll booth in an hour, the number of knot holes in 14 linear feet of pine board is the number of occurrences during an interval. Huh? Did I skip something? Okay, all right. Here's the formula for Poisson manually. We all remember this. And here's the first example that we studied, but now we gotta use the table with this. So here we go. Patients arrive in an emergency room in Mercy Hospital at an average of 6 per hour on the weekend evenings. What's the probability of 4 arrivals in 30 minutes on these weekend evenings? So, help me out with this. Do I need a 1 minus in front? This is asking for the probability of 4 arrivals in 30 minutes. Do I need a 1 minus in front?
No.
No. Stick with equals. Poisson, what's my x? 4. 4 arrivals in 30 minutes, comma, what's my mean? What's my mean? I'm sorry, I can't hear you.
3.
It is 3. It is 3. Don't forget, when you have a Poisson, you got to look at the interval in the question and adjust the mean, convert the mean to be the same interval. Since the question was about 30 minutes, but the mean's about an hour, we had to adjust the hour mean to 30 minutes. 6 per hour would be, like you guys said, 3. 0 or 1 on the end? 0, because it's only asking for 4 arrivals alone. Not 4 or more, not 4 or less, 4. There's the Excel, 430. Now, the formula, just real quick, just to review. What number would be right there where that mu is right there? 3 it is. That is the mean. What would be it to the power of? 4, because x is your 4. E 2.71828 to the power of negative what? 3, very good. And then the denominator would be what factorial? 4, you got it. Okay, good. Let's go to the table now and solve this. Okay, we're gonna have, this table only needs a column and row. You have to identify column and row using Poisson. So here we go, column, row. Column is going to be your, what is it, I forgot, your x? No, your mean. This is going to be your mean, and row is going to be your x. That's that easy. Can you believe it? Are you ready? The mean in this question, you guys said, is because it said usually there's 6 arrivals in an hour, but the question was about 30 minutes, so you said the mean was 3. So we have to go to this chart and try to find a 3 along the top. That's our column. Column is a 3. So let me scroll it down a little till we can find the 3. It should be right down below here. Since there's a 1 on the end here, and there's a 2 on the end of that one, there's probably a 3 right here. There's 3. Okay. Whoops, let's show the whole thing. There. All right, now, row. Row is x. You told me the question was asking about 4 patients arriving in 30 minutes, correct? So, this would be a 4. Does that sound right? So we would go to x equals 4, the row is 4. Look where that, here is the column for 3. Where's my pointer? Right there's 3. And now take this down to where it says 4, and my pointer is right next to the answer. 0.1680. Right there it is. Now, I want you to, hang on a minute, look at this. Right here. Look at this, what had to be calculated to get 0.168. And now, look at what we had to do here to get 1.68. We just had to find the column and row. Help me with Excel. Help me with Excel. No. I want to experiment with this other example. We're going to page 184 if you happen to have your book. By the way, look at this. You know what this is? You know what I'm trying to say right here? What am I trying to say right here? What is this? Crude oil price. Do you remember what it was when we started this semester? It was like 78, 75, right in there. It just hung out in the 70s, high 70s. It's all the way down to 65. Do you know what gas price should be normally if crude oil is at $65? Gas prices should be at $2.90. But it's not. I keep running the list to figure out what gas prices are. The lowest I'm seeing in this area is $3.27, $3.28, and $3.29. There's a conspiracy going on. I want you guys to investigate it. Alvin, go ahead.
The interest on saving accounts is higher.
Yeah, that's true. What would that have to do with the price of gas, though? Oh, I don't know. All right, you ready? We're using this chart. Here it is. Oh, wait, no, that's right. We're going to the book when I forgot. All right, hang on. We're doing the book one, but we're gonna experiment with this one. I'm gonna ask you to solve it several different ways. We're going straight to B on this. We can now address the question, this is the whole thing about Ann Jones was managing the coffee place, what's that called? Starbucks. She's specific question about the probability distribution of the customer arrivals to the store. Ann believes that the typical Starbucks customer averages 18 visits over 30 days. 18 visits over 30 days. All right, there's how the mean is described. We know this is Poisson because we've been talking about it. So you know whatever the question interval is, if it's not 30 days, that's what has to be converted. If it's not 30 days. Hey, matter of fact, what if this question were about 10 days? What would the mean be? 10 days. 6. A third of 30 days is 10 days, so a third of 18 is 6. All right, what if the question was about 15 days? What would the mean be? 9. That's right. If it's 18 in 30 days and the question's about 15 days, you've got to convert the 18 to a 9. Half the days, half the mean. You got it. All right. Here's the question. B. What's the probability that a customer visits the chain 5 times in 5-day period? It's asking about 5 visits in 5 days. All right. Let me erase this. What is X? What is X in this question? 5 it is. 5 visits. What's the probability of 5 visits in 5 days? 5 visits or more, 5 visits or less, what does that say? 5 times, 5 visits in 5 days. What is our mean? What's our mean? Go ahead. 3. It is. It is 3. Because 5 days is, what is that? A sixth of 30 days. So if you have to divide by 6 to get to 5 days, then divide this by 6 and get to a 3. And a 0 on the end because it's asking for exactly 5 visits when usually there's 3 visits in that interval of 5 days. There's how we did it using Poisson. If we were using the manual formula, 3 would be the mean, 5 would be your X, 2.71656. Let's use now the table. Let's use the table now to get this. Hang on. Minimize this. Minimize this. What column am I supposed to be using? I can't hear you. What column? It is 3. Because the mean is 3, and that's your column. Happens to be the same column we're in right now for that last problem, just a coincidence. We're trying to find the probability of 5 instead of 3, so we use row 5. My pointer is right next to it right now. There's our answer, 0.1008. 0.1008. Just barely above 10%. I look at the book, and it says on page 185, that manually calculated, this will be 0.1008. Same exact answer. Stay with this table, You ready? What's the probability a customer will visit 5 times or more? Let me put this. 5 times or more in the next 5 days. We're staying with 5 days. That leaves our mean at 3, but 5 or more. Tell me what I got to do with this Excel. 1 minus in front. Very good. 1 minus in front. Is this, what's this number? 4. It's got to be changed to a 4. The opposite of 5 or more would be 4 or less. Very good. The mean is still 3. The other change, a 1 on the end. All right, now, you're answering this question on the final exam, and you're using a table to answer it, and I'm saying, give me the columns and rows and ends or whatever you need to give me, because I don't want to give away which table it is, so I'm not telling you exactly what you need to give me, but you need to know from this lecture that you're giving me the column and rows. And in this case, because it says 5 visits or more in 5 days, you're going to give me more than just 1 row. So help me out here. I'm going to column 3, right? 3.0 as a matter of fact, to be exact. And what rows am I going to use to answer the question, 5 or more? Tell me.
Go to 5.
5. What else? 6.
7.
7.
8.
8.
9.
9.
10.
10.
11.
11.
12.
As far as it goes though, right? From there, anything above 12 would be 0%, or so close to 0 they don't even need to list it. Because look at 12 itself. Now there was two ways to answer this. Someone else could have said using rows 4, 3, 2, and 1, and then subtracting from 1. 1 minus these rows right there. 4, 3, 2, and 1. I don't even care if you told me you subtract or not. As long as I'm seeing that you're using these 4 rows, that's correct. Or if someone said I'm using these, what is that, 4, 5, 6, 8 rows, that's correct. I'll take either answer. I'm so happy that you're using the correct rows. Go ahead.
On the final exam, are you gonna tell us to use the chart?
It's gonna say, yeah, you have to use a table, and you're gonna have to give me rows, give me the name of the columns and rows, or any way that, as you learned in class, and the table will be attached. The pages that you need will be attached to the final.
Thank you.
You're saying we don't have to download the table, it's on there?
No, you should have it anyway, but the pages you need, like, this whole page would be on the back of your final, knowing that you need to find the 3.0 and what numbers off it. But you're gonna see the 2.0 and maybe the 4.0 on that page also. Yeah. But I'm not gonna put the whole table attached to it. Cause there's a chance, I don't know, different tables kind of look different ways. I want us all to be using the same table, so that's why I thought I would attach it. So we'd all have the same answer then.
So the mean is 3 and there's 5 customers. So it'd be like 10% and 8 is, what is that? Is that all?
Yeah, for, you're trying to say for 5 or more,
No, just 5. That's all.
5 by itself is 10%, 0.1008.
So this is not more or less. It's not like there's each one.
No, right. This is for each individual number, and you'd have to add them all up for 5 or less. That's a good question. Matter of fact, if the question said, what's the probability of 5 or less, you'd have to add 5 plus 4 plus 3 plus 2 plus 1 plus 0 to get that answer. Now, if it's a shortcut, if I said, hey, what's the probability of 9 or less in 5 minutes? Let me write this down here. Hang on. Ready? 9 or less in, hang on, I'm changing it up. Look at this. 9 or less in 15 days. Help me out here. 9 or less. Getting rid of the 1 minus. Get rid of this, get rid of this, get rid of this. Hang on. Hang on. Here we go. Help me out with Poisson. 9 or less in 15 days. What's my X? Okay, hear you. 9. Comma. Comma. What's the mean?
9.
What?
9.
What a coincidence. What's the number on the end? 1. 9, 9, 1. We cut the mean in half because we went with 15 days, so that makes it a 9. And I just happen to be asking about 9 or less. But now, to use this chart, we got to go to the, what is it, 9. Does this even go up to 9?
Yeah.
Heck yeah. There's 9. Oh, look at that. This is 9 or less, so I would go column 9, rows 0, 1, 2, 3, 4, 5, 6, 7, 8. Is 9 included? 9. I'd have to add all those up. From my pointer, hang on, where's 9? From my pointer up. Look at the probability of 8 and 9. They're the exact same probability. So about 13% plus another 13% makes 26, plus 11 makes 37, plus I'm adding 10 makes 37, 47, plus 6 makes 53, plus 3 makes 56, 57, 58, about a little more than 58% adding all those numbers together. Can we use this table? Just to make sure, one last question. What's the probability of 4 or more in 15 days? 4 or more. I just want the table now. 4 or more for 15 days. Let me erase this. 9 is still the column, but what rows would I use?
3.
Give me the shortcut.
3. 4.
Right? We would add those together, the opposite of 4 or more, and subtract from 1. Those would be the rows I'd use. Did I do something wrong?
No, I was just wondering, like, on the test, would it be possible to do, like, 1 through 3?
Yeah, you mean right, no, you have to use 0.
Oh, I mean, like, yeah, but like...
Oh, but you're saying instead of like this, just go,
Yeah.
yeah, sure. Everybody see what he just asked? Instead of writing each individual row, if it's a long one, you could just put 0 through 3. But please don't forget the 0 for sure.
So you have to add those, all of them up?
If it's asking for the answer off the table, you would have to add all those up and then show me you're subtracting it from 1, because this was for 4 or more. You'd have to add all those up and subtract from 1, because the question was for 4 or more in 15 days. Tables aren't that hard. It's just a matter of remembering this stuff.
So if it's
And the only two tables you're learning, you already know about normal distribution table, Z table, Z chart. These are the other two tables. There's no other tables after this. Binomial distribution table and Poisson distribution table are the two tables you've learned today. Okay, we gotta learn the if function. That's our big thing today. Everybody think we got this table down? Anyone need another example that's odd, like a less than or a greater than or equal?
So if it's like
We're okay? Go ahead.
We're just subtracting the one question?
Yes, yes, he's asking about when to use -1. Are you talking about for this or are you talking about here? This one, you wouldn't have to use 1 minus, only if you're going the route of finding the opposite of what it's asking for. For example, this question said, use the table to find 4 or more in 15 days. So 4 or more, you really would have to add up 4, 5, 6, all of these down as far as it goes. But the only reason you got to subtract from 1 is if you take the shortcut. The opposite of 4 and more would be adding 3, 2, 1, and 0 and subtract from 1. So that's the only time. So when you're using the table, you have to decide whether you're subtracting from 1 based on whether you're adding the ones being described or the opposite of what's being described. Go ahead.
Could you do the mean again?
Yeah, you ready? Wants to see the mean again? I'm gonna give you another one, and it's gonna go like this. Hang on, help me out with the numbers for this question. What's the probability a customer visits Starbucks, hang on a minute, 6 times in 10 days? August, ready?
Yeah.
Ready? Hear me. What's X? Tell me what I'm asking about. 6. 6 visits in 10 days. Now here's where you gotta convert. You tell me the mean. Now think about it. It's not 18 in 30 days. It's gonna be how many times in 10 days? I gotta think about what the answer is.
6.
You hear everyone?
Yeah.
You see how they got it? They said, well, to convert 30 days to 10, you had to divide by 3. So divide that by 3. And it's just a coincidence that I picked the same number.
When was that 18?
That was given in the problem.
Oh, that was given.
That was given. This is what we keep converting.
Okay.
Because we keep using different days other than 30.
Okay.
If it's 5 days, you gotta convert to 5. If it's, what else did we use? We used 15 days, you had to convert it in half. 10 days, now you need to use a third of that.
Yeah.
All right. I think we got it. All right. You ready?
I have a question.
Yeah, I'm ready.
So, say the probability was like 0 or more. Would you put -1 for X?
No. No.
No?
No.
Alright.
And he wouldn't be able to do it. It'd be 100%. It includes every number. Then you might as well just put, the answer is 100%. 0 or more includes every single number.
Okay, I got it.
Right, and they always add up to 100%.
So for the equation, we wouldn't have one.
Yeah, you wouldn't have one. I mean, you wouldn't be able to solve it. Because you can't use a negative number. I would never ask you for 0 or more because the answer would be 100%, but that'd be a good trick, because you know how I like to trick you guys. What? What do you mean? He gave it to me. Okay, you ready for the if? We talked about if, and I showed you one way, very common way if statements are used, and that was that simulation, right? So, hey. Okay, so here are some other ways. I'm gonna make this nice and big. I want you guys to see this. Here's some other ways to use if statements. Now here's the data. The data goes from, what is this, C7 all the way to C31. All right, so this first way I should demonstrate, it says, here's the part about an if statement. Matter of fact, I should have had this up here. Right after you say if in the parenthesis, this is the question you're asking Excel. And you have to ask a question that either is going to be true or false. So it has to be asked in a way where Excel just goes, oh, this is true, or oh, this is false. one or the other. If it's true, right after that first comma, after the question, it's telling Excel what to do. So look what it says here, equals if, parentheses, C12 greater than 100. There's the question, hey Excel, go look at C12, is it greater than 100? If it is, if that's true, right after that comma, you're telling it to put the word greater there. After that comma, you're telling Excel what to do if it's false. So it only is gonna do one or the other, based on that question. In this case, it went to C12, it saw that it was greater than 100, and so it put the word greater there. If it went to C12 and it was not greater than 100, it would have placed the word not greater there, in that spot. To prove it, let me show you what I'm gonna do. I'm gonna take this number 112 and make it 99, and watch how the answer changes. Now it says not greater. I'm gonna put it back to 112, and now it changes back to greater. Okay, next. This one is combining different Excel functions with the if statement, which you can do all the time. And it's saying, hey, if the average from C7 to C31 is less than 90. So it's telling Excel, go to all the data from C7 to C31, figure out what the average is, and is it less than 90? Is that true or false? Now here's the bad news, if it's equal to 90, the Excel will kick this back and say it can't solve. It should say less than equal to, just to include, just in case it does equal 90, but it says less than 90. If it is less than 90, it will bring back the words less than, comma, if it's not less than 90, it'll bring back the words greater than. So sure enough, the average was less than 90, so it brought back the words less than. Now I'm gonna take that 112, I'm gonna make it such a huge number that it will make the average be greater than 90, and it will change the words to greater than. Let's see if I can do this. And now it says the average. See it now? It's that changed to greater than. Let me widen that up so you can see it. Now I'll bring this back to 112 again, and it will go back to less than. And there it goes. It went back to less than. So it's another way to use if statement. Now we're heading to where my favorites, where you use an if statement. You got a question. If it's true, you tell it what to do. But if it's false, you ask another if statement. And then if that one's true, you tell it what to do. But if it's false, you ask another if statement. And that's where Excel programming comes involved. Because you have layers and layers of if statements, checking every possible thing that you need to check, which is very common in simulations. So that's why I want you to, I think one of these go that far, I can't remember. So this one says, if C7 is greater than 25, now it's saying, if that's true, go and count if C7 through C31, how many of the cells have A, B in it. Now this is only if it's true. I want to make sure I repeat this. This is saying, look at C7, and is it greater than 25? So let's look at C7. It's 33. So yes, the answer is it is greater than 25. So Excel goes after the first comma and says, okay, now Excel says, you're telling me to count all the cells between C7 and C31 that have A, B in the cell. And sure enough, it's saying there's two of them. Let's take a look. They're probably down here at the bottom. There's one right there, AB, and there's another one right there, cell C23 and C30. So that's why it came back with the number 2. Now, I want to do the opposite here. What was it looking at? C7? If C7 is greater than 25, I'm going to make C7, instead of 33, I'm going to make it something less than 25, so that it brings back the word no instead of 2. So it's 33 now, I'm going to make it 20. And look at how the word no just appeared here now. Bring it back to, put it back to 33, and it brings back. You're getting these, huh? Hang on, it keeps going. Now, if you use greater than and less than together, just like you see right here, if C8, that means not equal to. Not equal to. If C8 is not equal to 22, then put not 22. If that's not true, then it must be equal to 22. So put the word equal there. Let's go to cell C8. It's 23. So it's not equal to 22. That's why the word That's why it placed the words not 22 there. Good. Wait, did you have a question?
Yeah, I was gonna ask about when it shows two, the two ifs.
Yeah, the two ifs right there.
Where
the
the-
count if and the if.
Yeah. When you put the second count, when you put the count if, the data there, what's gonna show AB? What's the condition?
Say it again. What's it gonna what?
What's the condition? Like why
The
is it
condition
what
is at
what?
AB. It's looking if there's any ABs in this list, and there are.
Oh.
Well, watch. There's two of them down here. There's an AB right there where I'm pointing, and there's another one right there. That's why I brought back the number 2, because it got told to count if there's any ABs. Count if from C7 to C31 ABs. So because C7 was greater than 35, it went and looked at the whole range and counted how many ABs, brought back the number 2, because there's 2 of them.
And if C7 wasn't bigger than 25.
It would bring back the word no.
No.
And to show you, hang on a minute, let me get there. I'm gonna change it to a number less than 20. Now watch how that 2 turns into a no. Ready?
Yeah.
See that? Now I'm gonna put it back to 33. Whoops, hang on. And it changes back to a 2
Two.
again.
Because there's two ABs.
Because there's 2 ABs.
Okay. Yeah.
Exactly. But the whole point of that really is just to show you how you're combining another Excel function with an if equation. And this one, again, this is just showing you how to use not equal to. Matter of fact, let's make cell C8 equal to 22 and watch what happens. The word, it will change from not 22 to the word equal. So here we go, 22. And now the word equals here instead of not 22. Put it back now to 23. It changes back to not 22. Okay, here's another one.
Wait, I have a question.
Yeah, go ahead.
So for the last one, what if it was like equals, if C8 equals 22, then equal, then not 22? Can you do that?
What do you mean equal then not equal?
So for the first.
Hang on, hang on.
Right.
Right here where the 2 arrows are, you want me to change that to an equal symbol?
Yeah, we'll just put an equal symbol.
Just
there.
put an equal there. Anything else change?
And then the not 22 will change equal, and the equal will change not.
That's right. That's right. So, right now, because there's a 23 in that cell, the way it is, it's gonna bring back the word equal, right? No, it's gonna bring back the word equal, when really they're not equal. 'Cause
I was
it's-
saying flip it too.
I know, I will, hang on.
Okay.
See that? But if I flip it, it will bring back not 22, you're right. So hang on. He's just changing the logic behind it to where the responses are the opposite of what they were.
So if this was asked on an exam, we can give any answer?
Yeah. Or I might give you the if equation, you gotta tell me what the result's gonna be that will show up in that cell. By looking at the data. That could be the way it's asked. Or you could be asked to write an if statement, you're correct. I'm adding that to the homework, as a matter of fact, either writing an if statement or you telling me what the if statement will do. I want that included too. Okay, this one, this is saying, now this is saying, if, here we go, if cell 29, C29 is greater than 50, let's look at C29, is it greater than 50, first of all? If C29 is greater than 50, C29 is the number 34, so it's not greater than 50. If C29 is greater than 50, then put greater than 50. Then now we have, if it's not greater than 50, we have another if statement. And it says, if C29 is less than 30, which it's not. But if it were, it would say put less than 30. If it's not, then it says put between 30 and 50. So it comes back with between 30 and 50 because the number down here is 34. It wasn't greater than 50, then it jumped over here and found out it's not less than 30. And so it said that. What would happen if I put the number 55 here? What will come back? What will be placed?
Greater than 50.
That's right. Watch. See, now it says greater than 50. Then you put it back and make it 34 again. Now watch what happens when I change it to
25.
less than 30. I'm going to change it to a number less than 30. So I'll make it 20. And now it says less than 30. Put it back at 34. And now it says it's between 30 and 50. So you can see how it's identifying a number to decide if it's greater than, or less than, or between two numbers. But what I want to point out is how it's using an if statement And because, if it were false, it asked another if statement. And if that were false, it could ask another if statement. If that is false, another if statement. It could go on. And there's several things in simulation where you need to be able to have that asking questions until you narrow it down to what exactly it should be, and then determining what to do. All right, so now, here's a question you might see on an exam or on your homework. Instead of me showing you an if statement and you telling me what the result's gonna be, you have a question that says, write an if statement that will determine if the median is greater than 70 or not. The result should be stated as if it is or not. So it is or not is the result. I'm not gonna show you it. Help me through this. Ready? Equals. What do I put next? If. Then what? Parenthesis. Now, here it is. We're supposed to write an if statement that will determine if the median is greater than 70. What should I write next? Median? Sure. Why not? Now what should I do? Median, then what? Parenthesis, I heard. That's right. Now the range of the data. This is going to be tough. Hang on. I got to go all the way to the top here. I'm going to left click on the top of it and hold my left click down and drag it instead of typing it all out. There we go, right to there. So C7 to C31. So if median C7 to C31, then what do I put? Comma? Or do I put parenthesis? Parenthesis. Then what? Greater than. Because it's saying, is the median greater than 70? So put it greater than, then probably 70, I guess. Now, what do I put? What's next? Comma. You've now asked Excel the question. Either this is true or false. The only thing I might add to this is put greater than equal. No, I guess equal would be the opposite of greater than, wouldn't it? And this is only saying, write an equation that if the median's greater than, not equal to, greater than. Now, if this is true and the median is greater than, what's the words we're supposed to bring back? Does anybody remember? You can't see it, but do you remember?
Oh.
Hang on, let me scroll to the right so you can see. What's the words I should bring back? Hang on, I'm going to use quotation. It is, comma.
It is not.
Or just, I think it says just to put not. I think it says stating it is or not. I don't know. Parenthesis. This should do it, right? If median C7 to C31 is greater than 70, comma, if that's true, put it is. If it's false, not. You guys saw the numbers. Do you think the median, now remember what median means, the center, do you think it's greater than 70? Do you think the words it is or not is going to show up?
Not.
Or is it not going to work? I hear one not. That's all I hear. Is this being recorded? Believe me, there's a class here. There's a lot of people. So make a little noise so we know there's people here. Yeah, all right, good. There's actually a lot more than that. Anyway, you ready? I heard one person say not. Let's see if they're right. Now, we did this off the top of our head. Let's see how it compares to the answer that was already there. If median C7 to C31 greater than 70, oh, this is a much more expansive answer if it's true. The median is greater than 70 if it's true. If it's false, the median is not greater than 70. All right, we took the shortcut and just put the word not. Same thing. I think you're getting this. Can you guys write if statements? Can you read if statements?
Yes.
If you're given a sentence that says, write an if statement that will determine the median is greater than 70, could you write that? Thank you. Thank you, Abby. At least we know someone's in the back row. All right, so that comes to the conclusion, except for unless someone walked in late, Amir, Michael, Desmond, Shandri, Julia, Matt, none of them are here. So my last thing I have that I wanted to mention is I want to prepare you for your real life career. You will graduate eventually. You know that, right? Most of you? Won't you? Is there someone here that may not graduate? I hate to say that.